Alright guys, we're going to pick up where we left off. I think I already went over the slide about average rate. Again, looking at slope, rise over run. Remember, the y's can be written as f of x, okay? I'm just going to evaluate. And I'm going to try to fly through this as fast as I can because I'm ready to go to bed. Find the average rate of change from the intervals -1 to 0. Remember, these are x's, okay? And we're going to want to write points. We're going to want the x1, y1. We're going to want the x2, y2. So you know what x1 is, that's -1. x2 is going to be 0. So if you look at y1, x1, it's -1. It's right there. So the y is 0. If you go to x2, is going to be 0. Go up to the line, it's at 2. Follow the formula from the previous page. We're going to go 2 minus 0 all over 0 minus -1. That's part of the formula. Let me just rewrite the formula here so you don't think I'm cray-cray. Okay, that negative is part of the formula, so we still leave that negative there, because what do two negatives make? That's right, a +1. So the answer is 2. Example 2 says find the average rate of change for intervals -2 to 1. Again, I'm just going to go straight to writing the points now because it should be painfully obvious by now. I'm just looking for points. So -2, 1. So if we go back to -2, down to the line, it's -1. Go over to the 1 and up. I'm going to argue it's 6 for this one. Again, set it up. 6 minus -1 over 1 minus -2. That turns into a positive. Yeah, I might put it in red. That turns into a positive. That turns into a positive. So 6 plus 1 is 7. 1 plus 2 is 3. And that's okay. 7 over 3 is perfectly fine. And if you want to write that as a decimal, well, just plug in your calculator. 7 divided by 3 is going to be, well, I got to get out of this, don't I? Here we go. 7 divided by 3, 2.3. So I'll go back to my slides here. 2.3. Alright, let's keep going. And again, I'm going along with that worksheet I left you. It's in that folder. Alright, I flipped my paper over. I got number 3. So, again, these are x values. You would simply plug them in for the x to get your answer. So we're going to have 2, and we're going to have 5, and we're going to plug these in. Now, I'm going to remember it's 3 of x minus 2, so I'll grab my calculator. I'm going to go 3. I've heard people call this button the caret, but I need it to get that exponent position up there. So our first number is going to be -2. I'm going to hit the down arrow to get out of that. And we're going to, oh, it's not, goodness, there's no negative right there. Alright, that's better. Because again, I'm plugging it in as I see it. -2. Hit the enter, 7. While I'm on the screen, I'm just going to go ahead and get the next number. And that's going to be 5. So change that x to a 5. 241. 7 and 241. 7. Who put that 0 there? Should be 241. Who did that? I think I blame Cody for that. Yeah, I'm blaming you, Cody. Let's check. 241. Yeah, that's right. So plug it in. 241 minus 7. 5 minus 2. Again, I'm following that formula. Okay? So 7, 11, 4. So this is probably 234. 5 minus 2 is 3. Again, if I were to add 7 to that, I'd jump back up to the 241. Now, here's a trick. 2 plus 3 is 5. 5 plus 4 is 9. This number is divisible by 3. So I'm going to get my calculator, plug that in. 78. So my answer is 78. Let's keep going, plugging in 0 and tree for that. So I'm just going to go ahead and get my points ready. And we'll plug that in my calculator. So 3 parentheses, 2 parentheses, caret, and we're going to plug in 0. I'm going to get out of that, and minus 2. Oh, wow, we get 1. Alright, let's go put that equation back in it. And then I'll change that to a tree. And then we get 22. So 1 and 22. 1 and 22. Again, using the formula that we were just talking about. Let's see, 22 minus 1 is 21. Over tree, basic mathematics, 7. Okay, just following formulas. Now we have a table. It says find the right change between 1 to 2. 1, 2, 1, 2, 3. Oh, jeez. So we're looking at the 1 and the 3. 1, 1. Again, using the y values here. And looks like 3 and 9. Again, real quick, plugging in the formula. Again, 8 over 2. Mental math, 4. Now remember, you could hit pause and try to do this on your own. Come back here and play and see if you're getting the right thing. Okay? Again, we're using this chart for these answers. I'll put it in red this time. We're looking at 1 again. And then we're looking at 5. So let's write that out. We got 1 again. And 5, a 1. I'm just going to turn my music down. Work on this until I get back. Alright, I'm back. 81 minus 1 over 5 minus 1. We get 80 over 4. Pretty sure it's going to be 20. Because, just tag the 0 off. 8 divided by 4 is 2. Yep, check. It's manifest. I'm doing a great job. Flip your paper over. It says find the average rate of change for each of the following graphs over a Gantt interval. We can ignore that because you already have this paper. Remember, I'm going to count. And conveniently, we already have these dots. 1, 2, 3, 1, 2. That's 3 over 2. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. 7 over 3. Rise over run is what I'm doing here. And then 1, 2. 1, 2. We went down, so it's a negative 2 over 1. So negative 2 over 1, negative 2. Okay, guys, that easy when you're just having to count. Let's keep going. Ah, jeez, what are you doing? Go away. Go away. Go away. Why is it still here? Go away. There we go. Okay, sorry about that. Again, pause the video, try this out on your own. I'm sorry I'm whispering. Remember, I'm doing this at a hotel. I'm trying not to wake up my neighbors. It's called respect. Suppose 25 flower beetles are left undisturbed in a warehouse bin. The beetle population doubles in size every week. The equation P of x 25 times 2 raised to the x can be used to determine the number of beetles after x weeks. Complete the table. Guys, I'm plugging this into my calculator so I can fulfill this chart. So I want to go over here in my graphing calculator. I'm going to plug this into this function. 25 5 parentheses 2 caret x. Okay? And I'm going to go second table. And look, I'm just going to plug these values in. Obviously, I'm going to bounce back between the two. So 25, 50, 100. At the 0, 25, 50, 100. 25, 50, 100. And then we need 3, 4, 5. Let's see what those were. 200, 400, 800. 200, 400, 800. 200. Wait a minute. What's going on here? They're doubling. Oh, I didn't need to memorize it. I could have just doubled it. So now we need to calculate the average growth rate between 1 and 3 weeks. 1, 3 weeks. Those are your points. 150. And then tree 200. So I'm writing really small. 200 minus 50 over a tree 1. It's going to be 150. And that's 2. And we get 75. Again, I'm using this formula every time I'm doing rate of change. Okay? This one has it between 0 and 5. So 0, which is going to be 25. And then 5, which is 800. So again, 800 minus 25 all over 5 minus 0. That's going to be 5. 800 minus 25 is going to be 75. I'm going to use a calculator for that. So let's get out of this. 775 divided by 5. Ooh, that's too many sevens. Let's try that again. Why am I putting that many sevens? Why is it? Look at that, guys. Okay, there we go. Divided by 5. 155. 155. You may have to turn the mic up because, again, I am whispering. Which average growth rate is higher? Why do you think it's higher? Which one's a larger number, guys? That's right. 155 is greater than 75. So which growth rate is higher? We're going to say the second one. Because, why? Why is the second one greater? That's right, Gabe. Because this is between 0 to 5 weeks. And this is 1 and 3. That's like 2 weeks. And this one has 5 weeks. Because, we're going to say because the longer time span. Okay. Yeah. No, this is easy. Okay. Let's keep going. Let's see. This is right beneath it. It says given the function blah blah blah. Find the average rate of change. Look, guys. By now you should be able to pause this video, grab your calculator, and plug it in. All right. Now that we're back, go ahead and plug in these values. I'm just going to go straight to the answers. We're going to have 2. This will be our first quarter. 4. And our second quarter. So I'm going to plug that into my handy calculator. Let's see, 225. Okay, so 2 times 2 raised to the second. And we're going to add 5 to that. We got 13. Again, I'm going to go right back up here. Change that to a 4. And we get 13 and 37. 13, 37. So, again, following the formula. I'm telling you, all I've been doing is following this formula. We got here 4, 10, 24 over 10, 12. Mental math. Alright. I can't do this in my head, so the first one's going to be -2. Second one's going to be 2. Plug that in my calculator. Here I go. Parentheses alpha y equals enter. We get 1 over tree. Parentheses caret. And we're going to go to the -2nd. I was looking at my paper, guys. And -4. Hit enter. Boom. 5. Reuse that same equation. Again, maps turn headphones up because I'm whispering. I have to whisper because remember I'm at the hotel. I'm about to not bug people who are trying to sleep. What do we got here? -3.8. For the sake of teaching, I'm just going to put this at -3.89. -3.89. Make this bigger. -3.89. The other one was 5. Okay, so 5. Nope. Got a little distracted. There we go. We're going to go -3.89 minus 5 all over 2 minus -2. Again, that turns into a positive, so that's 4. This is misleading, so I'm going to plug that in my calculator. We're going to go -3.89. Subtract. Did I say subtract? Yeah, we got to subtract 5. Subtract 5. Get -8. Oh my gosh, I should have known that. It's like your head. These negatives, they both go in the same direction. -8.89. Oh, I did not know that. It shows you how I need to go to sleep, because remember, the last video I made, I stayed up until 2:30 in the morning. Or was it 2? I really don't remember. I'm going to take that and plug my calculator. That answer is already there, so I'm just going to hit 4. And we get -2 point. I'm going to write that in 2. So 2. That was tough. Why is this here? Go away. Why does that even pop up, guys? Alright, what's next? Alright, we're just gonna find the guys you can do the domain. Y'all can do this by now. Okay? Knock it out. Pause the video and knock it out. Now, I just looked up and there's a mirror right over my laptop. I'm looking at myself. And my eyes are huge. Why did y'all not tell me I had big eyes? Alright, here we go. Double backbone R. The range, again, asymptote's -2. So y equals negative. Oh my gosh. That don't go there. What goes here is how low can you go? Put in -2. How high do you get? Positive infinity. This is really -2, guys. X-intercepts. I'm thinking we're going to put in -1, 0. Y-intercept. I'm thinking it's a good 0, 2. It is increasing. And wait, let's get some points. So -2. And -2 is -1. So there's my first point. 1. And what do we got here? 6. So again, 6 minus 1. And we got 1 minus 2. 7. Tree. Man, what a coincidence. It's like we've seen it before. Oh, and remember, 7 over 3, remember this turns into a plus. It turns into a plus. Alright, moving on. Skadoosh. Let's see, did I give you this worksheet? No, I did not. So we're going to click through here until we get to that worksheet. Look at all these problems I should have gave you. You should thank me. But hey, if you want to challenge yourself, pause the video and knock it out. You need this. Guys, now we walked into transformations, linear functions. You really need to write this down. As you know, f of x, again, same thing as y. Reflect over the x-axis. The negative tells you if you're reflecting over the x-axis. 4 is going to control the stretch if it's greater than 1. Shrink if it's... I don't like this terminology. We're going to change this. We're going to say between 0, greater than 0, x, still less than 1. Okay? Because I don't want you to get confused with this negative. This negative, its job is to reflect it. This number, whatever numbers are here, its job. Okay, your slope, remember mx? Your slope controls if it's stretching or shrinking. This is new terminology we need to start learning. If it's greater than 1, we say it stretches. If it's less than 1, we say it shrinks. Okay? And that plus 15 is a shift up or down. Obviously, up is a positive, negative is down. Again, these are new vocabulary words you need to start learning. You've probably heard of them maybe in 8th grade, but you need to start relating the constant as the shifting up and down. That m, your slope, whether it's stretching or shrinking the graph. The negative controls reflection of the x-axis. Again, write this down. You will need it. It should be that other worksheet in your packet. Given that the parent function y equals x, what shape are these graphs going to be? Guys, this is the shape. Linear. That's a word we use like all the time. Graph the parent function y equals x. Easy peasy. Again, you can just use these points. Y equals x. I'm literally just copying the same thing I just wrote. Watch your points, you'll notice we're just going up one. I want to cheat and use my line tool. Don't know why it's black, but whatever. Put some arrows on that bad boy. Boom. Done. Get on my level. Now, the whole point of this is to show you where we're starting. I need you to see what happens when we add that 1 to it. Watch this, watch this. Negative 2 plus 1 is negative 1. Negative 1 plus 1 is 0. 0 plus 1 is 1. 1 and 1 is 2. 2 and 1 is 3. Okay, that's going right here to these points. Still, the slope's 1 over 1. Guys, I need you to look at something. Compare these two graphs. Let me dress that up a little bit. This line right here. Guys, look at these two graphs. What's the difference? What happened? That's right. This one went up. If your parent function was right there, that line went up 1 unit. Okay? That's what this worksheet's all about. It's showing you these transformations. Ah, go away. Alright, you ready? Here we go. Skadoosh. Guys, you should be able to graph these. Take the initiative here. Pause the video. And see if you can't see. Okay? Alright, here we go. It's like this stupid box is trying to get on my last nerve. Alright guys, I'm just going to freehand this out of like respect to me trying to go to bed. So if I reuse these points again, minus 1, so we should have negative 3, negative 2, negative 1, 0, and 1. plot these points. I already know what's going to happen. It's a -1. We just talked about it shifting down. This line shifted down 1. Okay. Remember, going back to the notes, we have 2 shifts right here. It's reflecting, and it went up 1. Okay. This went down 1. And be prepared to start listing these things. You're going to have to list them for the test. Again, just going back to the usual coordinate points. Plug it in. Guys, 2 negatives make a positive. 2 plus 1 is 3. Negative, negative, that's a -1. Times that negative makes it a +1. 1 plus 1 is 2. 0, no such thing as a -0, so it's 0 plus 1, so it's 1. You see the pattern? We're going down by 1. Okay, so -1 is 0. 2, -2 plus 1, -1. Plot these points, -2, 3, 1, 2, 3. -2, 1. And we got 0, 1. We got 1, 0. We got 2, -1. Guys, this makes sense. Because remember, this is a negative slope. Look, this one. If we were to flip over that line, it'd be negative. All this should be tying together. You should be wrapping all this stuff up that we've discussed when it comes to linear lines, okay? All this should be starting to make sense. Let's do this one. Again, I'm just going to pick the same points. Keep it simple. Do this in my head. -2 times 2 is -4. -1 is a -5. -1, -2, -3. 0, 0 is -1. Guys, you should see a pattern emerge. We're adding 2 every time. Okay? So if we plot it, we get a -2, -5 down here. That's a 4, that's a 5. -1, -3. 0, -1. 1, 1, that's right here. And then 2, tree. Really on. Granted, my line's crooked, but I'm trying to go to bed. So look right here. We have a down 1, and that 2 means stretch. Stretch by 2. Let's just go ahead. We're going to reflect. 1/3, we're going to know we're going to shrink. And we'll go ahead and say by 1/3. And we're going to shift down 2. So I'm cheating, guys. I'm going to put numbers there divisible by 3. -6, -3, 0, 3, 6. I'm doing that because that's a 1/3. I'm making this easier for myself. Again, 2 negatives make a positive. 6 divided by 3 is 2. 2 minus 2 is 0. -3, 2 negatives make a positive. 3 divided by 3 is 1. 1 minus 2 is a -1. 0 is just 0. 3 is -1, -3. I think you already see your pattern. So -6, 0 is right here. -3, -1. 0, -2. 3, -3. Oops. Right here. And 6, -4. Again, my line is freehand, so it's going to be a little crooked. I mean, that line's fly. Makes sense. It's negative slope. It's laid back a little bit because it being a 1/3, and it did shift down 2 for the first. Okay, let's fill out some notes at the bottom. We should be able to do this too. Just think about it. We're using our new vocabulary words. What transformations do you observe when a number is added or subtracted to the parent function? Added, shifts up. I'm going to try to squeeze subtracted right here. Subtracting, shifts down. I'm sorry if you can't read it, blow it up. You should be able to once you make it full screen. What does a negative do in front of the parent? Reflect. Reflect. Number greater than 1 is in front of the parent. Stretch. We just took notes on this. A number less than 1, greater than 0, shrinks. Okay, these are vocabulary you're going to need to know. Jot this down. Or if you've already done it, you should be checking your work, because you should be working way ahead of me. So flip your page. I'm almost done. I just got 2 more pages to go over. But I'm trying to show you something. That's how easy this stuff is. We can fly through it. We just have to focus. Taking a little break from the worksheet. Let's try to re-emphasize what we've learned. Pause the video. I want you to pause the video and write down all the transformations for me. This is good practice. See, there's 4. 1, 2, 3, 4. Here, I'll put it right there. So you can pause the video and jot them down. I'm writing the transformations. I'm about to burp. I didn't burp because I tried to keep it silent. Because again, I'm in the hotel. I do not want to disturb anybody. I also really want to go to bed. I gotta wake up at like 6 or something like that. Or maybe not 6. 5:40. I don't know. I need to hurry up a bit. Alright, are we done here? So this one we're going to reflect. We're going to stretch because of the 2. We're going to shift down 3. This one, almost the same thing. No reflection. We are still stretching. And we shift up 3. We got a 3rd, which means we shrink. And we down 4. Oops. Let me try that again. Down 4. And again, shrink. Up 4. If you got them right, you get a smiley face. If you didn't even bother doing this, you get the sad face because you're turning into a real disappointment not following along with the video. Anyway, yay, I'm glad you did work it out. But I'll give you like 3 strands of hair. And just like me, he has no neck. My head and neck are really the same thing. Also, I found out a new trick, guys, since I've been out here in the conference. If I hit this button, and then I hit this button, I get a paintbrush highlighter, shape recognition pen, magic pen. I think, no, not magic pen. Paintbrush. No, not paintbrush. Create pen. Yeah, look. Look at all these smiley faces. But trust me, this isn't the only thing I learned out here. I'm going to bring back a lot of cool tricks. So anyway, let's keep going. Guess what? Yep. It's time for you to jot down some more notes. Now, look, this is a pretty big slide, so maybe I can shrink it. Let me find out. See if I can shrink it. Oh, almost there. Let me shrink it a little bit more. Perfect. Perfect. Guys, that's right. You need to write this down. Transformations, exponential functions. Okay? Again, this could be y, could be f of x, doesn't matter. First one, flip the function, reflect over the x-axis. Reflecting. Sometimes I'll say flip, but we're reflecting, okay? A Again, just like before, stretch if it's greater than 1, shrink if it's less than 1. Okay, I'm telling you, these rules you'll see playing out all through math, and they're about to go, they're pretty much the same thing all through math, school, I guess, math, school math, school is cool, math is in school, that makes math cool, yeah it does. Again, you're going to move right, left. I need you to understand this moving to the right when it's negative or moving it to the left when it's positive is counterintuitive. Meaning, when you see a plus sign, you kind of want to move to the right, which I get that. Or even when it's a negative, you want to move to the left. But I'm telling you right now, when these numbers are written like this, and you'll learn in geometry too about quadratics, strange things happen, okay? You got to think backwards, okay? Now, we're going to prove that when we graph these things, how they do go the opposite direction than what you think it should do. But the sooner you pick this up, the better. Again, that thing we're adding or subtracting is our asymptote. Has a double meaning. It's also your shift up or shift down. Again, just like the linear equation one, at constant controls if it shifts up or down. So write this down. These are good notes to have. So pause the video and jot them down. Look, we're almost done, okay? Almost done. Let's keep going. So given the parent function y equals bx, what shape are these graphs going to be? Okay, what are they going to be? They're going to be curved, in my opinion. That's a D. That's a D. And you know what? Let's try right there. Curved. What's my pen doing? Like starts off skinny and then it gets, yeah, whatever. So -2, -1. Guys, this is a repeat from before. Okay. Let's see if I can remember. 0 is 1 as always. 2, 4. I think this is 1/2. 1/4. 0.25. This is 0.5. I think that's right. Asymptote 0. So here's my asymptote. It's going to go through the 1. And then 1 is 2. 2 is 4. And this is half. And this is 1/4. And again, it gets closer and closer to the asymptote. It doesn't touch it. Okay, and to prove my point, look what happens. +1. You know that makes the asymptote go up to the 1. And watch what these points do. Watch what these points do. 0 is going to be 1. 1 and 1 is 2. This is going to be 3. This is going to be 2 and 2 is 4 + 1 is 5. Okay, -1. This be a point. Oh my gosh, that's beyond me. Let me punch in the calculator. You get to that point where it's just too late to do math. +1. I knew that. 1.5. 1.5. I'm just going to go back to the calculator. Change that to a -2. Look, man, I'm telling you, if you get this calculator down, you can fly through this stuff. Fly through this stuff. So, -2, 1.25. -1, 1.5. 0, 2. 1 tree. And 2 shift out. Again, draw your line. It's curved. Not touching the asymptote. A little crooked there, but it did shift up one like it said it should. Let's see what the time looks like. Oh my gosh, 40 minutes. we're going to wrap this up. How about we just write the transformations? That's right. We're going to go to the right 3. And this one is going to reflect because of that negative. That plus 2 means it's going left 2. Again, you can plot the points, graph them, use a graphic calculator, etc. Let's fill in this 14 real quick. A number is added or subtracted to the parent. That control shifts up when it's positive or down when it's negative. A number added or subtracted to the exponent left when it's positive, right when it's negative. Again, these are shifts. Negative is in front of the parent function. That's reflection. And when will an exponential function stretch or shrink? Remember, when that a is greater than 1, it stretches. And when that a is less than 1, it shrinks. Okay, and to reemphasize that, we're not including the negative. The negative has its job. It reflects. After you distinguish that, ignore it. Look down at the a. Is the a greater than 1 or is it less than 1? So here's some practice. Again, we're going to write the transformation. So go ahead and pause the video. Try this out. All right, we're back. Really quickly, yes, we're going to shift up. And if you want to be extra, shift up by 5. Got exponential here. Now, we've been learning some new words, so I'm going to go ahead and give this 3, and we're going to call it growth rate. Okay? I'll say growth rate 3. I'm going to say growth rate by 3. Just to give that a talk because it's telling me X. Because I want you to look down here at 20. We got 2 different numbers with that X. 11 has one job, and that's to shift up by 11. Over here, that half is less than 1, so it's a shrink by a half. And plus 3 means it shifts up. Alright, look at this. Half. Remember what we said? That's right. Decay rate. And you know what? I might even argue I really feel like I shouldn't be using the word rate. I'm thinking factor. You know what? Let's use factor. That'll really make us sound smart. And I'm all about making sure y'all sound smart. Let's put factor. Yeah. Factor. Factor. Decay factor by a half. This one makes it go up 1. And that guy, remember, negative means we go to the right by 1. We got that negative and makes it reflect. We're going to say the 6 is a growth factor. And plus 5 means it goes left by 5. Shoot, we are getting so good at these. Now check out how I'm going to write this one. Reflect. And I also want you to notice something. I'm going left to right, and I'm literally writing each one's job. So the negative reflects. The 2 is greater than 1, so growth factor. Oh my gosh, guys. I want to put growth factor on that 5. That 2, remember, in our notes has a job. Draw an arrow from the 2. That 2 is going to be that stretch that we were talking about. And I know it's so confusing to distinguish the two. But if you go back to our notes, this was an A, this was a B. And remember, we associated the A to the stretching and shrinking. But that B, remember, that was that factor, that rate, that number we were using to multiply several times with. And the number that tells us what to multiply by how many times is that X. Anyway, 8, up 8. Shifting up 8. Alright. Again, I'm going to just fly through this last part because I care more about you know what these transformations are. Because let's face it, you should be able to graph anything I give you at this point. So, I'm just going to put transformations. You can plot these. Go ahead and pause it. Go ahead and graph it if you feel the need to. I feel like if you're still struggling, you still need the practice. So go ahead and graph it, compare it with your buddies, because frankly, I really want to be done with this video. Alright, we're back. Transformations. Guess what? We have reflect. We're going to have a stretch. And we're going to have a we went down 4. Okay? Again, stretch by 2, down 4. So the next one, again that 2, I'm just going to go ahead and start using it. Growth factor by 2 or up 2, whatever word you want to use. Plus 3 next to that X means we went left 3, and then negative 2 means we went down 2. Okay? Again, pause the video, try these out, or really just finish the whole page, and then I'll just fly through the answers real quick. That'll be the thing to do. So pause the video and try to answer these real quick. Alright, here we go. Whew, let's see if we can fly through this. 3 makes it stretch, and then negative 10 means we went down 10. Oh, I could be done before 11. I could go to bed. So negative makes it reflect. 3/4 means it shrink. And we went up. Again, I'm being real quick about this. Negative makes it reflect. 4 means it stretch. 7 means it went up. 2, we're going to argue the fact that that's a stretch. By that 2, I put by 2 underneath it to remind you. 4, we're going to argue it's greater than 1, so it's a growth factor. And that's it. Oh, we're almost done, guys. We are almost done. 3, stretch. We're in the home stretch. Negative 2, that means we went down. Reflect. 3 is greater than 1, so we're going to say there's a growth factor. Plus 2 means we went left 2, down 5. Oh, we're almost there, guys. A 3rd means it shrinks. 2, that's a growth factor. And then 4 means we went down 4. Almost there. Grand finale. Reflect. 2 is greater, so it's growth factor. Negative 3 next to the X means we went to the right 3. That's an R. R. And 8 means you went up 8. We did it, guys. We did it. We did it. We did it. Hooray. I'm done with this. So are... Wow, I think SmartNote just closed itself. I looked away and looked back. I hope this recording still works. I just want to cry. I had a surprise at you at the very bottom of that page, but it didn't work. That makes me sad. Alright, good night, guys. Work hard.